Today we're looking at the lab called Determination of the Ideal Gas Law Constant, R. Now the ideal gas law is this right here, PV equals nRT, and the pressure could be measured in kPa, millimeters mercury, inches mercury. Volume could be measured in liters, milliliters. N, of course, is just measured in moles. And T has to be measured in Kelvin. R, on the other hand, could have a number of different numerical values. For example, 8.315. If you have kPa for your pressure, liters for your volume, and of course moles, and then also Kelvin temperature. Now, if you had the pressure measured in something besides kPa or volume measured in something besides liters, then the actual value of R would be different. So we are going to try determine experimentally this value of the ideal gas constant. We're going to do it using this chemical reaction right here. But first, let's take a look at some of these chemicals. This is magnesium metal. We usually store it in a plastic bag to keep air from reacting with it. It should be nice and shiny. Usually before we do labs with it, we like to take it and sand off the oxide, magnesium oxide layer that may have formed on it to get it down to the nice shiny metal like this. Now you might recall using magnesium a couple times in labs that we've done before. Magnesium is kind of interesting because it can actually burn quite readily in air. Let's actually see what that might look like. Here, I'm going to hold it with this forceps right here. And if I light it, we can see how it burns. Let's do that again. Here's a lighter. I'm going to just catch that little corner on fire there. Ooh, it gives off quite bright flame. If you were not seeing this in video, you'd want to not look directly at it, or you'll be seeing spots like I am. Notice what happens to it. Magnesium turns into a white powder, magnesium oxide. Magnesium oxide. Now that's not the reaction we're actually going to do in this experiment, though. We're going to react magnesium with hydrochloric acid, which is another thing that I think we did in a previous lab. Let's take a look what that might look like. Hydrochloric acid is a strong acid. We'll learn more about that later in this year. What I'm going to do is take a little bit of it and put it into this test tube. And then we're going to add a little piece of magnesium metal to it. This will be the reaction we actually do in this experiment. I'm going to ball it up a little bit so that it can go down there. And you can see that it reacts quite readily with the hydrochloric acid. Now this is a reaction we're going to do in the lab. It's going to produce aqueous magnesium chloride, which will stay in the test tube, and hydrogen gas, which is right now just floating away out of the test tube. In our experiment, though, we're going to try to collect that hydrogen gas and measure it. So that's the reaction that we're going to do. All right, again, it's going to be magnesium plus hydrochloric acid, and that's going to give us magnesium chloride. That's going to stay aqueous, and hydrogen gas, which are these bubbles that just go right up out of the test tube here. Okay, next let's take a look at the procedure. Number 1, obtain a gas collection tube called a eudiometer and a 600 milliliter beaker filled with tap water. Alright, what is this going to look like? There's our beaker. And a eudiometer is essentially a very long test tube like this. And has graduates on the side like a graduated cylinder. Usually you use it kind of upside down like this. And that's going to get clamped into this burette clamp right there like that. And the reaction is going to happen inside of it. Alright. Number 2, obtain a stopper that has a length of copper wire on it. Alright, that's this piece right here. And the little piece of copper wire is going to hold our piece of magnesium when we do the reaction. Alright, next measure a 1.5 centimeter piece of magnesium using a ruler and cut it. Find its mass. Alright. Okay, here's our magnesium, about 1.5 centimeters. Now, what we do need to do is find out the mass of it. We have to put our magnesium on the scale. Now, it would be better to have a more precise scale, but this is the best we got. 0.02 grams. Next, we're going to secure that on our little piece of copper wire. The purpose for this is to keep the magnesium from floating away. So essentially like that, and that's going to go in our eudiometer. Next, we're going to put about 15 milliliters of the hydrochloric acid into our eudiometer. Take a long time. Okay, we have our acid in the eudiometer. The next thing will be to finish filling it with water to the top. Now, hydrochloric acid is more dense than water, pure water, so it should remain at the bottom of the eudiometer. We're going to fill this all the way to the top. Then we're going to put in our piece of magnesium. Our magnesium now is clamped into that little piece of copper wire. That's going to go right into the top of the eudiometer. Carefully. It's going to overflow a little bit. Whoops, I'm going to see what I'm doing there. And now when we tip it over, now we have to get our eudiometer upside down into this large. So I'm holding this on this end, submerge that in there, and then the acid will start to flow down. You can see the acid coming down. Eventually it's going to hit the magnesium and start to react with it. Let me get it in the clamp here. see it. As the acid comes down, it will start to react with the magnesium, creating hydrogen gas. Let's see if we can zoom in on this a little bit better here. There it is. You can see the bubbles forming on the hydrogen. They are now making their way to the top, collecting at the top of the eudiometer. All right, this will take us a little while. So we're going to let it sit and react for however long it takes until all the magnesium is gone. Okay, it's still reacting. Bubbles rising up the eudiometer, collecting in the top, making some progress. See what our volume is so far. About 8 milliliters. We'll let that keep going here now. Okay, let's record some data here. We have our mass, which we determined to be 0.02 grams of magnesium. Volume of the H2 collected, we'll get that when it's done here. We also need the atmospheric pressure and the temperature. Next, we need the temperature and pressure. So for pressure, we have our gas sensor, and for temperature, we're going to have our thermometer. We're going to assume that the gas in the eudiometer, which is now done reacting, it will be the same temperature as the water that is in this. So we have 17.1 and 29.09. So 17.1 and 29.09 inches mercury. I'll leave for you to convert that into Kelvin. The reaction is done, and we should get our final reading of the volume. It looks to be 29.50. 29.50. Translated 0.0252950. Yeah. Sorry about that. 0.02950 liters. All right, that's it. The rest is some calculations. Leave that for you.